Howdy, everybody. Here for day 3 of Advent of Code. Um, I thought though we'd just start by looking at day 2 really quick. Um, I didn't change a lot. Just today was a busy day, so I did do some briefly looking around and reading some comments and stuff and some of the other solutions. It seemed like brute force was the simplest thing. The people who tried to like find an elegant solution, and by I put elegant in air quotes because it turned out to be like pretty complex, and there were a lot of edge cases that would work for some inputs but not others. So the brute force seemed to be it. So all I really did was simplified the way it looks. I changed. I don't remember what it was called before, but we now have an is valid report function, and then we have a could be valid, which does the part 2 where it like removes values and does that, and that just makes this right here, this main function, look a little bit cleaner. So that's all I did with respect to that. So given that, let's do day 3. Oops, I should probably zoom in when I do it. Okay. Calendar day 3. Excuse me. Okay, our computers are having issues. So I have no idea if we have any chief historians in stock. You're welcome to check the warehouse, though, says the mildly flustered shopkeeper at the North Pole Toboggan Rental Shop. North Pole Toboggan Rental Shop. Apparently, this was from previous day. I don't remember a lot of the days. The historians headed out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? The computers appear to be trying to run a program, but its memory, your puzzle input, is corrupted. Okay. All of the instructions have been jumbled up. It seems that, ooh, is this like a mole? Okay. All of our instructions have been jumbled up, but it seems like the goal of the program is to just multiply some numbers. It does that with instructions like mul xy, where x and y are each 1 to 3 digit numbers. For instance, mul 46, 44 multiplies 2024, mul 123. However, because the program's memory has been corrupted, there are also many individual characters that should be ignored. Even if they look like part of a mul instruction, sequences like mul 4 star, mul 69 bang, question 1234, or mul 24 do nothing. For example, consider the following section of corrupted memory. 24 mul. Okay, so there's some that are like really close. I guess the key to like figuring out how far you go. I mean, it's just straight up that these ones are like valid ones, right? Like I'm wondering is there any like could you go deeper in like nested moles? I don't see any in this example. One of the four. Only the 4 highlighted, excuse me, these 4 are real instructions. Adding up the results of each instructions is 161. 2 times 4. Scan the corrupted memory for the uncorrupted mole instructions. What do you get if you add them all up? Okay, how big is our input? Okay, there is a lot of input. Are there multiple lines? I mean, I guess it doesn't matter, right? Yeah, there are multiple lines. But I guess it doesn't matter because you're just looking for moles. And presumably the new lines don't matter. I mean, I don't see any place. don't see anywhere in particular where like a mole would cross over a new line. That's what was just going through my mind is, do I have to worry about new lines and stuff like that? But let's take the test example to so we have that with us that we can kind of peruse. Can I turn on word wrap? View word wrap. Okay, that's just so we can see it. I can find a good place. Okay, so but we ought to think about like how do we solve this? Uh, like state machine is good, right? You search for MUL left paren, and then you expect 1 to 3 digits, comma 1 to 3 digits. You could even use something like nom. Ooh, that would be interesting. Just use nom to find the valid ones. I haven't used nom in a long time. I think I tried to use it on one of the previous days for the input. I don't know if I shared that in the video though. That may have been like after the fact. Because like what nom would do is it would look for specifically this thing and then it would just fail right here. But then you go to the next character and then you'd get one, and then you'd keep failing until you got to the next one. That would be the idea. You basically go until your string is empty looking for the values, and then you sum and multiply them. Okay, so that's, I mean, that's definitely an option. You could just do regex, right? Regex is probably easier than nom. I have I even used regex in Rust? It doesn't, it's not in the standard library. It's just a crate. I mean, you can do captures though over multiple parses. I mean, regex may be the easiest. Is it POSIX compliant? The crate provides. Looks like it does something similar to like the Go version, where it doesn't do some of the regex stuff, like negative look aheads and stuff like that. Or I don't remember what they're called. Look behinds. There's several types of regular expressions that you can implement, but it changes how you're able to like the efficiency of the search and find. I actually haven't used this regex, so that might be fun to try and use that. I mean, I have used nom before, so that might be easier. I don't know. Maybe let's see. Am I gonna? What's gonna bite me in part 2? Maybe I just don't worry about that and start with regex, and if nom becomes like what I'm thinking is like you see like these thens and stuff like that, and these plus signs. Like I'm wondering if there's eventually some kind of um additional work that we have to do, and then the regex is for naught. But I'm probably just overthinking it. Almost surely the simplest way is just to do the regex, right? And we are only on day 3, so Hold on a second. Okay, let's see here. Oh, I was just thinking we probably have to cargo add, what's it called? Regex. And while that's doing that, we can do let input equal include string, but we want test.text. Let's just see if we can't get the regex. So we want to look for mul that 0 to 9, 1 to 3, comma, then another one of these. Then an in bracket. Mul 2, comma 4, 0, 9. Should we do capture groups too? We probably want to do capture groups because we want to capture this and this. Yep, there we go. Perfect. So I don't know if you have never used this before. This was just the first one that came up, but there's regex sites that kind of do it live. Ooh, I should do it in Rust too, yeah. And it looks like it works. So you can see like it's gonna pull out the 2, the 4, the 5, 5, 11, 8, and 8, 5. So this is our regex. Somehow over the many years of I first learned regex like I don't know, it's probably been 25 years now. I read a book. We still use it to this day, even though it's. I mean, so I definitely think some people use it wrong, but anyway. So that's our expression, and then this regex crate is saying we create a new one based on the expression. We have our haystack. We have our results. They're just pushing results into it. Path, line no line, captures iter, returns the captures, which reports both the byte offset of a match in the haystack and the byte offset of the ending match capture for the regexes in the haystack. What is that saying? I may have to play with this a little bit just to see what it shows. So, does it actually return the whole capture? I guess I'm not reading this regex correctly. Oh, it does. So you can see this has 1, 2, 3, 4 captures. No. 1, 2, 3. Colon separated. What is. Oh, okay. Yeah, it only has 3. So it does return the actual value. Okay, so something like this works. We can just test it. Okay, so we could potentially simplify this by doing like let p1 equal re dot captures iter on input dot excuse me, map and sum. Yeah, perfect. There we go. And we just print line p1. I'll get there. So like that. Is that right? 161, yeah. So again, all we're really doing is we have our input, which is the haystack in the documentation. We have our expression, and then we run the regex, and we do all that. We do an iterator over the captures. We map that to, we have to turn the strings into integers, multiply them, and then sum them, and that gives us part one. There was a lot in the input. I don't know if it'll overflow, but let's just try it, see what we get. That is a big number, but it doesn't overflow. Good, part one, not too bad. Okay, so this is definitely easier than nom, right? In nom, I would have had to build some more stuff and do like a loop where I'm like looping through it. So I think the regex is the good choice, but we'll wait and see if that changes with parts two. As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. If you handle some of the corrupted conditional statements in the program, you might be able to get even more accurate results. There are two new instructions you'll need to handle. Do and don't. Enables future mul instructions, and don't disables future mul instructions. Only the most recent do's or don'ts instructions apply. At the beginning of the program, mul instructions are enabled. For example, you get a don't here, so that turns off until you get a do here. Because there's a don't. Yeah, these two instructions in the middle get disabled once there's a don't. Okay, so this is where like maybe having done nom might have been made it faster on this part now, because now we just also search for don'ts and do's, and when we find them we just flip a flag. Can we do this in regex? Let's try it. I mean, okay. So that does do it, right? Here's my wacky regex. Basically, these bars are alternatives, and they say, oh, match do's and don'ts. So you get your first match is this type, the second match is this type, third match is this type, fourth match is this type, fifth match is that type, so on and so forth. So I'm just curious. I mean, it may be as simple as doing this. If I run this on the test. It still gives me 161, so that's right. Oh, I didn't change any of this right here, so let me change the capture. I kind of want to go because the capture is now going to be different. Like if maybe I should just do you know what I should do actually? Let's just do this in part 2 so we don't have to worry about it. So I may not be able to do this easily this way, but for now I can just print the captures and see what it does. How's that actually different from up here? It's cap 1 and cap 2. Cap 1 and cap 2 because the 0th capture usually for regexes is the whole thing. Okay, so I mean that makes sense. Like I guess maybe the easiest way to check is to see if like this one is changed now because the numbers are actually 2 and 3 as opposed to 1 and 2, but we can check to see if they're none. I mean, we can actually just check to see if capture 0 is don't or do and then enable or disable. So let's do that. So what we'll do is we'll say let mute enabled equals true. So it starts as true, and then we'll do for capture in ra.captures iter input. So we'll do it in a for loop now, which is a little different. But we also want to do let p2 equal 0. And then we'll say if capture, okay, it's kind of figured it out for us. If capture 0 is do, then enabled is true. Captured 0 is don't, enabled is false. Else if enabled, do 2 and 3. Is that right? Yeah, 2 and 3. So we just do a mute here. So let's just review that. Part one doesn't change. Part two is we use like the or operators for the groupings to look for don't or do. And then as we're going, if we find a do or a don't, we just either enable or disable. And only if it's enabled, then do we do the work. I mean, that seems simple enough. 48, right? That was what we were looking for. 48, yeah. Okay, there you go. Part day 3. I mean, it is a regex one. It would be fun to maybe try and do this in nom. So we'll see how much time I have over the next few days. This one is one that I think you could actually do some parsing for. I mean, if you've done college work or college style classes, maybe just online or whatever, or through videos, there's definitely you definitely learn a lot about like state machines and stuff like that. I mean, regex is essentially just a state machine as well, so you could potentially build your own state machine. But again, that's kind of what nom is for. Is it simplifies that state? It does the internal state machine for you. You just tell it what you want it, what you're expecting, and how to spit it out. So, I, I mean, this feels good to me. I will just add another note too. Like a lot of people hate regexes, regular expressions. I'm personally not a fan of them for the some of the cases that I've seen. Right, if you're like checking if yours is much more complex than this, it's probably easier to like split up the string and do some smaller regexes or just do your own sanitation type things. This one you can see is kind of bordering on unreadable, right? Even here, you can see it kind of starts to become unreadable with all the slashes and stuff like that. And you have to become like a regex wizard to understand all this stuff. So that's where I kind of feel like I'm not always a fan of regular expressions, is because it's really easy to make them so complicated that no one can read them, and everyone just, when you see the pull request, you just assume that the regex is okay because you don't want to have to, try and grok it, I guess is the way to think about it. So um anyway, just be mindful when you're using regexes would be my only thing. But I think this is an okay case for it. You're literally looking for just chunks in there. Maybe again, maybe if I have some time, I'll try and do it with like nom or something like that. See if I can't find these things. Um, but there you go. There's day 3. I'd love to see how you guys solved it, how you went about doing it. Maybe you found some cool solutions. Um, or especially if you use like nom or any other like parser library to kind of like extract that information. I would definitely love to see that. In fact, I may go look. Let's see. Should we just look really quick? Advent code. Why do people think you need regex? Okay. There you go. I mean, this is a very okay. That's a great way to do it. Okay, I don't even know what regex crossword is. Oh, I see. Okay, there's 2 regexes and you have to get them both to work. Interesting. Okay. Uh okay, this guy just did a for loop over it. Let's actually look at some solutions. I love to read the memes because they're pretty hilarious. Yeah, regex. Don't do, and then the mole 1 to 3. Okay, so this solution's essentially the same as mine. Again, Python is more terse, so they get away with the tersity. Mine's somewhat more verbose. Bash. Okay, you could definitely do this in like Bash or something like that, mostly just because you can run a set on it. Yeah. Okay, and then they're changing the moles and then putting a plus in between them and then using BC. Yeah, that totally works. Um Pointer arithmetic like the old days in Python. So here's someone that says he's doing it. Valid start. Okay, so he's just basically he's kind of invented his own state machine without it looking like a traditional state machine, but he's basically just going through it, looks for the mole to begin, and then he checks for the numbers. And if he finds the two numbers and the end, where does he check? Yeah, he does right here. He checks to see if the last digit. Sorry, maybe you guys can't see this without zoomed in. But so he's kind of doing a state machine, whereas opposed what you'd normally do with a state machine is you'd have your start and end pointers and maybe like your capture groups. Like if you're interested in capturing those two integers, you'd have like the start and end of those positions and then what state you're in. And then you'd be looping through the characters until you found those states. He kind of just says, so this maybe isn't exactly a state machine because what they're doing here is just like gonna loop through all the characters. If I find a mole, I'm gonna see if it's a valid one and put it in there. Okay. Shameless cheesing part 2 with split. Oh, that's not a bad idea. You could just do this. You could split the don'ts and do's. And you just like delete the don'ts. Like from don't to the next do, you just delete it and then you use part 1 again. Nope, that's his name. Language rust. After years of using pest for parsing, I decided to learn nom now. The iambic pentameter better. Yeah, so this is not off too far off from how I was looking at it in Rust, right? Or thinking about it from Nom. What did he say he used before? Pest? I'll have to look at that. But yeah, so you can see he's basically just saying, "Hey, I'm looking for, the surrounding parts of the two digits. Going to do some validations on the digits, and if I find it, I return it." And then I presume what you do is you basically just go through it, and if you don't, he input match indices mole map. I actually don't know what match indices is. Returns an iterator over the disjoint matches of a pattern within the string slices. Interesting. Very interesting. So he can use this to kind of get around like looking for mole and failing. Like if you do this match indices, you know you're always at mole, and so you can just see if it works, and if it does, validate this, and then you can see here he does like the map of is it valid. If it's valid, return the value, otherwise return 0 and sum it up. Interesting. Yeah, my original thinking, I think this is a cool idea because my original thinking was actually, sorry, I'll zoom in again for you to look at it if you want. My original thinking was maybe you just like start at the first character and look and keep failing until you find a mole, but this match indices helps you find like the next all of the moles in the file. So do you do that for part 2? Much more complex. So what this mini zero is going to do is it's basically going to uh, essentially split up the string, right? Like, did you find a do or a don't or anything else? Oh, wait, what is this? Mole. Oh, it's this function. So he's saying, do I find a mole, a don't, or a do, or anything else is garbage? Oh, that's how you get around the while loop of just checking if you find. So you check for all these cases, and then like the base case is it's garbage, so we just throw it away. And then he just iterates over them and finds them. That is a cool way to use nom to do that. I will have to review this code, and maybe I can try and to replicate something similar. But essentially, what he's doing is he's trying to find like the ways to solve the trying to find these enums, I guess is what I'm trying to say. He's trying to find these enums, and once he finds those, then he can do a match on them. Very cool. And that's kind of a very rusty way using the match statement. Sometimes I don't know if I use that enough, but okay, I'll have to check this out. Anyway, those are some good solutions. If you did yours in Nom, I'd love to see it. Maybe yours is different than this. Let's check it out and we'll go over it together. But there's day 3. I'll be back tomorrow for day 4. I'm thinking maybe on the weekends, at least the weekends for me. I don't know when you're watching this, but the weekends for me, maybe I'll try and do it live on YouTube. And then obviously I'll still post the videos, but if you want to join in and chat and watch, you're welcome to do that as well. And help out maybe. As the days get harder, maybe I'll need your help so we can do it live together. So anyways, talk to y'all tomorrow.